All right, starting off lesson 5.4b, solving trig equations. It says find the exact value of the trig function given that sine u equals 5 over 13, cosine v equals negative 3 over 5. Both u and v are in quadrant 2. All right, so not much thinking to do there. They already tell you where you need to draw your triangles. All right, so for our angle u, we're in quadrant 2, and we have opposite over hypotenuse here. Opposite's 5, hypotenuse is 13. You could use the Pythagorean theorem to solve for the third side, or if you remember your Pythagorean triples, you'll know that this is negative 12. All right, and then for v, this is u, v. That's the reference angle. Okay, and let's see, we have negative 3 over 5 adjacent over hypotenuse, and using Pythagorean theorem or the triples, this is 4. Okay, now we have cosine of u minus v, so I could apply the cosine difference formula, which is cosine u times cosine v plus sine u times sine v. And I never like it when they use u and v together because it's easy to confuse the two, especially when you're writing it out yourself. All right, just be careful not to mix them up. All right, cosine of u, we have adjacent, opposite, hypotenuse, adjacent, opposite, hypotenuse. Okay, so cosine of u, we're going to have adjacent over hypotenuse. Cosine of v, we're going to have adjacent over hypotenuse. Sine of u, we're going to have opposite over hypotenuse. And sine of v, we're going to have opposite over hypotenuse. All right, simplify this, and we get 36 over 65 plus 20 over 65. And I get 56 over 65. Done. All right, next one, write sine of arctan 1 plus arc cosine x as an algebraic expression. Okay, now this looks crazy to start with. All right, we're going to apply the sine sum formula. So imagine this was theta, and this piece here was beta. All right, so when we apply the formula, we get this. All right, take your time, be careful. It's going to look a little crazy to start with. See if I could squeeze it in here. Sine arc cosine x. Yeah. Okay. Now what's going to happen here? Sine arc tan 1. Okay, so what's the purpose of this here? Arctan, that's the inverse tangent. You're looking for an angle measurement, and we're working in quadrant 1. Since it's opposite over adjacent, we have 1 and 1. That's square root of 2. Now this here is supposed to give you an angle measurement, x, right? We don't know what that is. Well, in this case, we do since it's 1 over 1. We know it's 45. But then I'm taking sine of 45, or sine of x. All right, and taking sine of x or 45 gives me opposite over hypotenuse, which is 1 over square root of 2. All right, so once again, this could be a little confusing. This is supposed to give you an angle measurement, right? But then you're taking sine of that angle measurement, which is sine of this angle here, which gives you this ratio, 1 over square root of 2. Now, for this piece here, we have cosine, arc cosine. So it doesn't matter which way you do it. Cosine of inverse cosine or inverse cosine of cosine, you're left with the variable. All right, all that disappears, you're just left with the variable. Then we have plus cosine arctan And once again, we're going to use this triangle here. And we have adjacent over hypotenuse, so that's 1 over square root of 2. And for the next one, we have sine of arc cosine x. Okay. So we have to draw another triangle here. This is a little complicated at first. Arc cosine of x. So that's the same thing as x over 1. So I draw my triangle here, and I have adjacent, which is x, and my hypotenuse, which is 1. And if I apply the Pythagorean theorem, I need to solve for y, so it's going to be x squared plus y squared equals 1 squared. I'm going to subtract x squared. Y squared equals 1 minus x squared. Take the square root of both sides. Y equals 1 minus x squared. Alright, so this is 1 minus x squared here. Alright, don't worry about the y anymore. Alright, and from that, then I have sine of that. So sine is opposite over hypotenuse. So that's just 1 minus x squared, but the square root of it. Alright, sorry if this is a little messy here. Alright, so from there I get x over square root of 2. And then from here I get square root of 1 minus x squared over square root of 2. And I have x plus square root of 1 minus x squared over square root of 2. Okay, now you could rationalize the denominator. It would make the expression look a little crazy, but this is actually all you need for your answer at the end. You don't need to rationalize your denominator in this case, because the expression is just going to look even more crazy. All right, so that's all there is to that. Let's go on to another example. All right, here we have to prove the cofunction identity. All right, so I need to take this and show that it's equal to that. Well, I'm going to apply the sine difference formula. So I have sine of x, then cosine of pi over 2 minus cosine x times sine of pi over 2. All right, and I'm going to create a triangle based off of that angle measurement. All right, rotating pi over 2, that's the same thing as 90 degrees. So I land here on the positive portion of the y-axis. So my adjacent, opposite, hypotenuse, or what? Adjacent is going to be 0, opposite will be 1, hypotenuse will be 1. So I have sine of x, and then I end up with cosine, which is adjacent over hypotenuse, and then cosine of x. And then sine, which is opposite over hypotenuse, which is 1 over 1. All right, so since I have 0 here, that's gone. And then I have negative cosine x times 1, which is just negative cosine x. All right, so I've proven the cofunction identity. There we go. Done. Next one. All right, this looks pretty crazy here. I have sine of a sum. I have sine of a difference. And the interval is 0 to 2 pi. All right, there's a lot going on in this problem, bringing together all the ideas from all the lessons so far. Okay, so I'm going to apply the sum formula. So I'm going to get sine of x, cosine of pi over 4, then plus cosine of x, and sine of pi over 4. And I have plus sine of x, cosine of pi over 4. And I'm going to have minus cosine of x, sine of pi over 4 equals negative 1. Okay, so this came from this, and this came from this. Applying the sine sum formula and the sine difference formula. Okay, so notice that these cancel out. All right, and let's see. Now I just need to work with this piece here. All right, and this piece. All right, I have pi over 4 in both. Let's construct a triangle. Pi over 4 is 45 degrees. So that's 1 square root of 2. So I have sine of x. And then I have cosine of pi over 4, which is going to be 1 over square root of 2. And then I have plus sine of x, and then cosine of pi over 4, which is 1 over square root of 2. And that's equal to negative 1. All right, what do I get from this? Well, now I have sine. Oh, these are both identical. So I have 2 sine of x times 1 over square root of 2. That's equal to negative 1. Okay, so now I'm going to divide by 2. I have sine of x times 1 square root of 2 is equal to negative 1 over negative 1 over 2. And now I'm going to multiply by square root of 2. These cancel out. Well, the sine of x is equal to negative square root of 2 over 2. Okay, we're still not done. I need to figure out what x is. Okay, so here I have opposite of hypotenuse. Hypotenuse is always positive. Opposite is negative. And what quadrants is opposite negative? 3 and 4. All right, so that's a negative square root of 2. Negative square root of 2. That's 2. That's 2. And that's the property of a 45, 45, 90. So that's negative square root of 2. That's square root of 2. And I know these are 45 here. All right, so last question is, what's the rotation to get these terminal sides here? Well, this rotation is what? It's 225 degrees. In radians, that's 5 pi over 4. How about for the other one? That's going to be 315 degrees. 7 pi over 4. Okay, and since we're confined by this restriction here, I do not add on 2 pi in this case. Okay, because I'm just going from 0 to 360, or 0 to 2 pi. And those are my two solutions within that restriction. All right, done. If you have any questions, please make sure to ask. There's a lot going on here now, as you can see. So you really have to be able to put all these ideas together. And you only can do that when you're familiar working with these problems. Okay? Get focused.